Assalamualaikum warahmatullahi wabarakatuh. We are from Group 35 in PBL3 and would like to present our CFD project with the title of Analysis of Airflow Inside the Computer Casing. Before that, let me introduce the team members. It is started with myself, Naufal Fauzaan Nurrahman, Mohd Shafiq bin Roslan, and Premraj Ravi. In our project, we have four main topics to be discussed about, and the first one is introduction, methodology, result analysis, and lastly, discussion and conclusion. In our introduction, we have five subtopics to be discussed. In our background of study, we like to know what kind of impact an airflow delivers to the functional of computer casing. The main function of computer casing is to contain all of the components inside of it, and it is said that the excellent performance of the computer is also determined by the airflow. So if the system is not getting or exhausting the flow it is needed, it is likely to cause a problem in performance. Our problem statement of this project is how does the number of outlets affect the airflow distribution on computer casing design? Our first hypothesis of this project is the number of outlets in computer casing are determining the airflow inside it, and it would have some effects on the performance of the system. So, for our literature review, according to Chang in 2000, there are many components inside the CPU casing, and it is very important for the users to keep the CPU temperature under control. According to Intel, if all the components are diffusing heat into a small region, the temperature might quickly rise. If the case is not effectively vented, the hot air might cause the system to overheat and it will cause a problem to the system. The objectives of our project is to analyze the airflow inside the computer casing with a different number of outlets, and secondly, to evaluate the characteristics and behavior of the flow. In methodology, I'll be explaining about the geometry. The project starts by constructing a desired geometry. We created our design using Autodesk Inventor, and we decided to make two models, which is the two outlet and one outlet design. The dimension is all the same. At first, sketch the front side of the case with 150 mm as the length and 300 as the height. Then we extruded the sketching part with 280 mm as the width. For the input and output parts, extruded the selected part with 15 mm depth.
Okay, next, mesh analysis. Every mesh analysis has been made using ANSYS engineering simulation software. For analysis, fluid flow, which is fluent, has been selected from the toolbox. The sequence of the fluid flow are shown as the figure. This is an example of complete sequence. After choosing geometry option, design must be imported. Design are imported from AutoCAD Inventor to ANSYS, and we put in the space script. Name selection can be made by right-clicking mouse and select Create Name Selection. The function is to declare the input and output of the design. To generate mesh, by right-clicking mouse, choose Generate Mesh to start the analysis of the design. In this case, we only use the default element size, which is 0.021846. Next, for the mesh details. On the left side, we have mesh details for casing 1, and the right side is the mesh detail for casing 2. Both of them we use the default element size, and the nodes for casing 1 is 14,368, and element 67,881. So and for casing 2, the nodes is 1,845, and the elements is 8,220. So for the next slide, this is the mesh detail for casing 1. Mesh detail and the statistic for casing 1. So next is for casing 2. For the setup, this is the front page for setup launcher after clicking setup function. Press start to start the process. So let's start the process. Okay, for the outline view, this function can be found at the left side of the screen. The value that we use in this analysis can be seen on the video after this. So this is the setup function from ANSYS, and as you can see, this is our design of computer case. This is the design with two outlets. So let's go to the general. At first, the type we use pressure base and velocity absolute and time steady. So next model. So for we use viscous lamina because this is the steady airflow for materials. We use air as the medium, and the solid we use aluminium. So the cell zone condition we use also air as the medium. Okay, boundary condition we have inlet and outlet. So from inlet we use 30 meter per second for velocity magnitude, and the outlet we use 0 for first outlet, and the second outlet also we use 0 as a pressure. Let's go to the report definition. So report definition, we select flow rate, or we declare flow rate as our what we need from this analysis. So from here, the field variable we use velocity, and the surface, this is what you can see. All surface are needed for this analysis. So okay, next go to initialization. So for initialization, just click initialize. So hybrid initialization is done. Next we go to run calculation. So for run calculation, the number of iteration we use 100. Then just click calculate. So from the calculation we can get the scale residuals graph and the flow rate of velocity and iteration. So these two graphs are important in our analysis. Let's wait until it's complete. Okay, this pop-up message show that our calculation is complete. So okay, and this is the graph for scale residuals, and this is the graph for flow rate of velocity versus iteration. So from this part, I think that's all. Let's move on to the next part. Thank you. From the setup that we have made before, we found the solution from casing 1. So this is the scale residual for casing 1 and console flow rate for casing 1. So next, okay, so this is the solution from casing 2, the scale residuals and the console flow rate. Okay, so after that we have flow rate versus iteration for casing 1. This is the graph of flow rate versus iteration for casing 1, and that is the flow rate versus iteration for casing 2, its graph. So next, okay, result from ANSYS for casing 1. This is the two outlets computer casing, and we can see the velocity at the back of the computer case is increases. So and at the bottom of this case, there is turbulence airflow occurred. The last part, result for casing 2. So this is the one outlet and one inlet computer casing. As we can see, the velocity of the airflow increases at the outlet of this casing, and at the bottom of the computer casing we can see the turbulence airflow appear. So the blue zone is the turbulence airflow, and the red zone is the velocity that increase. So I think that's all from me.
Good day, my name is Premraj. So let's move on to the discussion and conclusion part. The velocity versus iteration graph of the airflow pattern indicates that a strong flow exists through the heatsink, but it weakens at location far from motherboard. Furthermore, recirculation of air can be observed at 3 locations on the motherboard. The air enters the cabin through intake vent with an average velocity of 30 meters per second. The basic thermodynamic principle behind the computer casing cooling is convection. If the air is moving, then these heated molecules will float away, allowing cooler air to replace them and absorb more heat. Using a fan forces the air to move, providing a constant stream of cooler air to absorb the heat from the object and significantly increasing the rate of cooling. Case with two vents help to draw cooler outside air in through exhaust fans, expelling warm air through the vents. In one vent PC case, more hot air trapped at a certain location, making it difficult to flow out. The velocity drop from inlet to outlet is higher in one vent case compared to two vent case. Air cooling uses cases air as the primary cooling medium. Cooler air picks up the heat from a component and either airflow from case fans or natural convection carries the hot air away. More the number of airflow, the better the airflow and cooling process in the PC case. Okay, now let's move on to the conclusion part. In this research, the results are evaluated by using numerical approach. It was achieved by comparing between two different number of vents in the PC case. The velocity streamline was studied. However, in this experiment, the dimension of the case is constant for both, but we use different number of vents for both cases. The biggest contribution to heat transfer in the case is made through convection. Using two vents make the velocity drop of the fluid at the outer pipe lesser compared to the one we use one vent, as we mentioned in our hypothesis before. This happened because bigger airflow involved in the heat exchange.
That's all for our presentation. Thank you very much for listening. Assalamualaikum warahmatullahi wabarakatuh.